tutorial, we'll create a lighting layout for a stairwell based on this multi-story Revit building, and then export the geometry to LightStanza to evaluate whether the lighting design will be sufficient. So to start, we'll create a simple 3D working view in the Revit model to better focus on the staircase of interest. So to do that, you can enable the section box and then just make adjustments to the outer lying perimeter so that it's only focused on the stairwell that we'll be lighting. Once the section box is set, you may find it helpful to also hide certain categories temporarily under visibility graphics. For example, we can turn off the walls so that we get a better visualization of the stairs and the landings that we'll be adding fixtures to. We'll turn these back on before we export. This is just to give a better visualization of the interior. Next, we can use this 3D view to host linear fixtures to the landing surfaces, these landings and then the floor surfaces that join to the doorways. So if you already have lighting fixture families loaded, you can go to Systems, Lighting Fixtures, and then select the family of interest. Or if you need to load an additional family, you can do that on the Insert tab and click Load Family. But now let's host these to our face surfaces. So we can start with the first floor landing. And place an instance. The location doesn't need to be precise. This is just to get it hosted correctly, and then we'll make some final adjustments in our plan view. Notice these are 8-foot fixtures, so they cover the whole landing surface. You can adjust these using family parameters. For this family, the length is controlled using this body length instance parameters. Type parameters will work just as well if that's how your families are built. One more under this landing, and then a final one on this top landing surface. Actually, the final one should probably go on the ceiling on the 3rd floor so that that gets good coverage as well. And then place one more to light that last landing. Now that the luminaires are hosted to the correct surfaces, we can switch to different plan views to get them positioned correctly. So we'll start on the first floor plan. Here's the fixture we just placed. You can use the arrow keys or mouse controls to sort of get it positioned properly. I'll align it with this column line just so it's centered over the landing. And then we can start moving upward. So next go to the first floor ceiling plan and move that one into the correct position. Now moving up to the 2nd floor plan, notice we don't actually have any lighting fixtures visible in the stairwell. So you may need to make an adjustment to the view range if you notice this on your model. So we can just increase the cut plane so that it can engage the lighting fixture. Try 7 feet. And then now that linear is also visible, and so we can move it into the correct position. One other way to move things rather than using the arrow keys is just using the move tool to sort of snap the center point into the desired position. And we'll go up to the ceiling plan to move this one. And we didn't place any fixtures on the 3rd floor plan area, so we can just go directly to the 3rd floor ceiling plan, and then move both of these so that they're aligned with one another. And now with the lighting fixtures located, we're ready to complete the LightStanza export process. So first we'll load LS parameters if you haven't already done that. And then for these we'll want to make sure to copy the length parameter to the LightStanza length parameter. So find the body length that we just used, copy to LS luminous length, and set the IES basis length to ensure that the output is properly prorated for the 8-foot version of this fixture. And then before exporting, we can return to the 3D stairs view to confirm that the lighting fixtures are placed where they're intended to be. Just a quick orbit around, look at the locations, those look good and placed properly. So now we can also adjust our visibility graphics settings so that the walls get included. Or you can simply assign a view template. For this one we can use the Lightstanza default export, or any view template you like that'll include all the major surfaces. And then walking through the export wizard, we may want to adjust a couple of settings. So send it to the correct folder, choose the section box option, and select the 3D view of interest, confirm the view template is applied. And then for calculation grids, we actually want to leave these turned off for this export. We'll place the calculation grids manually on each step rather than the entire work plane. And then on the advanced tab, make sure to include the lighting fixture data so that the existing luminaire locations are included. And then you can click export. Once the geometry is extracted from the Revit model, the 3D model will appear in Lightstanza, where you can further the lighting design. We can use the Lightstanza 3D view to place calculation grids along each step. And like we did in Revit, it'll be helpful if we hide some of the layers in the 3D view. So we can turn off the walls so that we have a better view of the stairs. And I also want to get rid of this framing material. I'm not quite sure which category it is. It looks like the curtain wall mullions and the curtain wall panels, just so we don't accidentally grab any of those surfaces. Because we're hiding with the eyeball icon rather than switching them off correctly, those surfaces will still be included in the simulation. This is just to give us a better working visualization. Now we can open the calculation grids panel to add calc grids to each of the stairs. First, you may want to orbit into a position where you have a direct view of all of the stair treads just to make placement easier. Then we can use the add from surface option to place points on the first step. It'll be helpful to give it a descriptive name for grouping as well. And then for spacing, we'll actually probably want something a little bit tighter than the standard spacing that gets applied in automatic mode. So let's try 1/2 foot and then attach a point to the first step. So here we're getting 5 points, it looks like, actually 7 points across the step for good coverage. Typically you want at least 3 minimum, and then the tighter the point spacing is, the more precise the statistics will be. So this will do for the rest of the steps. To add points to the remaining steps, just repeat the process. Click from surface, confirm the spacing is still correct, and place them one at a time as you go up the staircase. I'll spare you having to watch putting points on each of these steps. Then we can just skip to the point where they're already added to create the groups. That sure was fast. Now with each of the individual steps assigned a calculation grid, we can switch over to the grid groups panel and create a statistical group so that we can get aggregated statistics for each of the steps all together. And now with the calculation grids panel still open, you can window select, and the selection will filter just to calculation grids. Just kind of a shortcut to make sure you're only selecting what you want. And you can right click, and then under the edit flyout, there's this groups option where you can assign them all to the step statistical group. Quick and easy, right? Now, optionally, you can also repeat the same process to get calculation grids on the landing surfaces. This will be faster since there are only 4 landings rather than the 48 step surfaces we had. So we can just use from surface and give this a descriptive name. And I think we can go with a wider point spacing for the landings. Let's try 1 foot and see how that looks. It looks like we're getting sufficient coverage, and so we can continue adding points to the individual landing surfaces. Notice that we are getting some of the floor area for these 2 landings, but because of the point spacing, points aren't actually being added to these. So these should be correct. If you're doing lighting power density calculations and need the square footage to be exact, you can also just draw these using the rectangle option instead. But I think the surfaces should do for this particular model. So now we can add those to the same group just by selecting them individually. Multi-select by holding down the Shift key, and right click and create the group. And then right click the selected grids to assign them to the landings group. And now with the calculation grid groups created, we're ready to start a simulation. Because we just hid the categories from view, the wall categories, rather than removing them from the simulation completely, we can start from this view just as it is. Or if you want to update the visualization just for reference, you can turn those categories back on while the simulation is running. Now with the calculations complete, you can interpret the report to see if you're getting good coverage. And so we get the typical illuminance graph, so you can look at the individual point-by-point values on each level. And because we created statistical groups, down on the statistical summary, we can review the results for each of the groups. And so we're getting 13.3 foot candles average on each of the steps, and then a little bit higher on the landings. And the average to minimum uniformity ratio is also looking sufficient. The IES, most IES standards recommend something below 2 to 1 for the average to minimum ratio. And so we're well within that simply by lighting the landing areas. We did not need to add light to the actual stair surfaces to achieve this. And so it's a pretty simple lighting design for a typical stairwell. When looking at stairs, they'll often also be considered a path of egress, and so you can use the same model to evaluate the lighting design's performance under emergency conditions. So actually for that, I'm going to turn the walls layer off again, and then we can designate just a few of the fixtures to be emergency fixtures to play in the emergency lighting design. So I'll pick the 3 that are towards the southern portion of the facade here, attached to the slab surfaces. So by clicking the luminaires panel, I can select just these 3 fixtures, kind of rotate to get to it. And then right click and under properties, if you check this EM button, those will be considered in emergency calculations as well as default calculations. You can also review the emergency output factor. If these are going to be on a battery backup, you could reduce this, but we'll use 100% for this analysis. So like we did before, just start the grid analysis and change it to emergency mode so that only those fixtures are included. Label the original calculation. Give this one a descriptive name as well, just to keep track. So now reviewing the emergency mode calculation report, looking at our minimum column, you can see we're still achieving the typical 1 foot candle minimum for each of the statistical groups. And so there's sufficient lighting for emergency coverage. However, the uniformity ratio is way off now. The average to min shot up to 11.2 just because we only lit 1/2 of the stairwell. So to get better uniformity, you may consider enabling additional fixtures in emergency mode. You could include these linears as well, or perhaps consider an alternating design just to get coverage on these landings, depending on the specific requirements of the project. I hope you found this helpful, and this is the most efficient way to do a stair light and light stanza. One shortcut, if you don't want to add grids to each of the individual steps, there is kind of another trick you can do where if you just create the grids based on a rectangular geometry, you can sort of finesse those into position using the rotation handles. Just be sure to unlock the grid position first. And if you hold down the shift key while you're rotating, you can get 1 degree rotation increments to kind of follow the profile of the stairs, and then move those into the step positions. This is comparable to the statistical group approach we showed earlier. If you do go this route, one thing to keep in mind is also the meter aiming. So notice after you rotate the grid, the meters are perpendicular to the grid, which is probably not what you want for stair lights. So if you take this approach, just go to the calculation grid options and change calc point orientation to up. So either approach is valid. Typically the rotated grid approach is a little bit faster, and the individual step group approach kind of gives you a better summary in the report. By creating grids for each individual surface, one kind of benefit of that is you can see the results on each step so that you can more quickly identify problem areas if there's one that's in the shadows. But either way, it can be a valid solution to evaluate stair lighting design in Lightstanza. Thank you.